Okay, so members, we are going to see the case 2 when we are given a point in a plane and any two power vectors in a plane. Here we can use two methods. The first approach is we are given two power vectors in the plane, meaning that we are missing a norm, and we have also a point in a plane. So we have a point in a plane, meaning that all we need to use the dot product formula, we need a norm. But remember we said in vectors, if you cross any two vectors, what you get is a normal to these two. So when you cross any two vectors, the result is a perpendicular vector both to these two vectors. And now, if these two vectors are parallel, now they are parallel to a plane, they are not parallel to each other, but we say they are parallel to the plane. So it means that if after crossing them, I will get a vector perpendicular to them. But because they are also in a plane, it means that also this perpendicular vector is going to be perpendicular to that plane, and so what we shall get is a normal vector. So whenever they give you any two parallel vectors in a plane, all you do cross them, that's how you get the normal. So they are giving me the first parallel vector, they are giving me u1 is negative 1, 1, 1, and u2 is 2, 1, 3. Meaning that to get my normal, I'm going to cross them. So my normal will be u1 cross u2, and I gave you a simple method. So this will be now now this will be, now you see, I told you the easiest method is you cover. When I cover the first row, you see I'm remaining with this one, so you get a determinant. So this times this time this is 3, minus 1 times 1, that will give you a 2. Then we say if you start with a negative, then you cover the second row like this. So what we are remaining with is negative 1 times 3, you get negative 3. We are getting the determinant of this 2 by 2 matrix that is remaining. Then 1 times 2, which is a 2. This will be negative 5, so negative 5, so this negative and this negative will give you a positive 5. Now when I cover the third, we say this times this, you get negative 1, then minus this times this, which is a 2, and that's how we get is a negative 3. So now this is our normal vector, and after getting the normal, we just use the islet n, where this is the normal, this is the normal point, this is the normal, and this is the point in a plane. But they gave us a point here, so we have it, and we have the normal from here. So we just substitute. Then the point is 3, 2, 1. So let us go down and see. When we note here, we have 2x plus 5y minus 3z equaling 2. This will give me a 6 plus 10 minus 3. And so my equation 2x plus 5y minus 3z becomes 16 minus 3, 13. Now, the second approach we are going to use is, now if you have any two parallel vectors, now you can use the second equation, which says that always our R is going to be plus lambda u1 plus mu u2. Now this one, the idea is we all need a point and then two parallel vectors. Now we have these two parallel vectors in a plane, so these parallel vectors are in the plane. Then we have also a point, so we can use this one also. Now the idea here is you eliminate one of the constants. Then you make the other constant the subject to two equations. So here is the middle point, which is x, y, z, equaling to a point in a plane the point which we are given is 3, 2, 1. Then plus lambda into u1 is here, negative 1, 1. Then plus mu u2, u2 Then from here we form the equations. You see that my first equation is going to be x equaling 3 minus lambda plus 2 mu. Then the second is going to be y equaling 2 plus lambda plus mu. Then the third is going to be z equaling 1 plus lambda, then this and this, we have plus 3 mu. So these are our 3 equations. So after getting those 3 equations, now we eliminate one constant, combine one parameter, and then you use any of these ones and eliminate one of the parameter. And after eliminating one, we have one parameter and we make it the sum digit. So from here, I'm going to use equation 1 and equation 2. This is equation 2. To eliminate now, start this one. I can easily eliminate this one. So I'm going to say equation 1 plus equation 2. I'm going to be having x equaling to 3 minus lambda plus 2 mu. Then if I add them, you saw we are having x plus y equaling 5. This will disappear. Here we are having plus 3 mu. Now we make this mu the sum digit. I take everything this side, so we are having x plus y. Now minus 5 the whole over 3 equaling 2 mu. And rename this equation 4. Now I also use another equation and I eliminate. So you start when I have negative at the post, this one works for me. So I'm going to eliminate this and this. So equation 1 plus equation 3, what will I be having? Have x3 minus lambda z then I add. Why am I adding? Because they are the same sides. If maybe I use this equation, I will subtract this and this, I will not subtract. Everything is going to be the same. If this one had a coefficient 2, I will first multiply here by 2, so that we eliminate that constant. So here, by this coefficient 1, I'm just adding equaling 4. This will disappear, then plus 5 mu. Making me a substitute here. I have x plus z, then minus 4 over 5 equaling 2 mu. This one is my equation 5. Now it's that equation 5 and equation 4, they are the same. All of them are equaling to mu. Meaning, of course, that my mu is equaling to mu. What does it mean? It means that equation 4 is equaling to equation 5. So x plus y minus 5 over 3 will be equaling to x plus z minus 4 the whole over 5. And I cross multiply, I have cross multiply this like that. So now I'm in right terms, so that when I take this side, I'll be having now this when comes this side is going to give me 2x. Then I'll be having plus 5y. Then when I bring this side I have minus 3z equaling 2. Now this is 25. When I take this side, it will be negative 12 plus 25, which will give me 13. So you see that members, we are having a similar answer. So either use this approach or use the first approach. Everything is going to give you the same thing. All of these are going to give you the equations of a line. I wish you the best. Try more examples about it.